Hello everyone, and welcome. Today, we're diving into a small but incredibly important molecule in organic chemistry, boron trifluoride, or BF3. You've probably seen it written above a reaction arrow and wondered what its specific job is. Well, let's break down exactly what this powerful reagent does. The single most important thing to understand about BF3 is that it is a potent Lewis acid. In simple terms, this means it is an electron pair acceptor. The boron atom at the center of BF3 is electron deficient. It has an empty p orbital and is constantly searching for a pair of electrons to complete its octet. This electron hunger is the key to its entire function in organic chemistry. Because it wants electrons so badly, BF3's main role is to act as a catalyst by activating other molecules. It accomplishes this by grabbing onto atoms that have lone pairs of electrons, such as oxygen, nitrogen, or halogens. One of the most classic examples is its use in Friedel-Crafts reactions. To add a carbon group to a benzene ring, BF3 can coordinate with a halogen on an alkyl halide. This pulls electron density away from the halogen, effectively making the attached carbon a much more powerful electrophile, almost like a full-blown carbocation, which can then easily attack the electron-rich benzene ring. Another major role for BF3 is in the cleavage of ethers. Ethers are typically very stable and unreactive. However, the oxygen atom in an ether has lone pairs of electrons. BF3 will readily coordinate with this oxygen, forming a complex. This weakens the carbon-oxygen bond significantly, making the ether susceptible to being broken apart by a nucleophile. It essentially activates the ether for a reaction. This same principle of activation applies to carbonyl compounds like aldehydes and ketones. BF3 can latch onto the carbonyl oxygen, pulling electron density towards itself. This makes the carbonyl carbon even more electron-poor and thus a much better target for attack by nucleophiles. This is often used in reactions like forming acetals or other addition reactions. In all these scenarios, BF3 is a true catalyst. It enters the reaction, makes another molecule more reactive, facilitates the desired chemical change, and is then regenerated at the end. So, whenever you see BF3, just think powerful Lewis acid catalyst. Its job is to make good electrophiles into great electrophiles by temporarily borrowing a pair of electrons. Thank you so much for watching. I hope this explanation helped clarify the role of BF3. If you found this video useful and want to learn more about organic chemistry, please consider supporting the channel by liking, commenting, and subscribing for future content. It really helps a lot. See you in the next video.